muted as you listen in. Remember to engage actively by sharing your chat session. And then let's speak one at a time. If you have anything to say, raise up your hand. If you don't just want to type, let's keep the discussion on topic, and then let's avoid spamming the chat box with links that are not within the topic. Also, I mean, we have joined on time, but let's stay true till the end of time so that we're able to get the full value of this meeting. And then let's feel free to ask questions. If you don't want to forget, just drop a question in the comment section. And when it's time, we're going to take the questions. And most importantly, let's connect and have fun and learn and maximize this session. So quickly go through the introduction of, I mean, of course, the agenda is welcome, then the session, Q&A, and then we're going to wrap up, as always, very brief and quick and impactful. Our session today is going to be taken by Honor Jesus Bazalil. And then, I mean, I hope I'm not I hope I'm pronouncing the name properly. She's a machine learning engineer and a statistics graduate whose work focuses on natural language processing for low resource languages, speech technology, and geographic natural language processes. Our research explored the limitation of current artificial intelligence systems in underrepresented linguistic context, particularly in education and speech evaluation. She has led and contributed to multiple community-driven initiatives. She has trained over 5,000 students and mentored as while mentoring aspiring data scientists across Nigeria. As a community builder and former Microsoft Learn student ambassador, she has also organized and spoken at many tech events while advocating for inclusive AI systems that reflect local realities. Her work sits at the intersect of research community and real-world AI deployments in Africa. So, I mean, I'll allow Honor to just continue blowing our trumpets in quotes and then take us into the fullness of this session. Hi, Honor, if you're ready, we're ready. And then I can stop sharing so that you can take over. Yeah.
Hi, good evening, everyone. Good
Hello.
day,
Good
wherever
evening.
you're joining from.
Good evening.
So, I think I'll be sharing my session now. I'll be sharing my slides now.
Sure. Going to stop sharing. Yeah, you have the floor now.
Confirm if you can see my screen.
Getting there. Okay, now we can.
Okay. So, I'll be speaking on evaluating ASR systems for African languages. So, over the last couple of years now, we've had a lot of African researchers work on ASR, on TTS, and try to gather our own local data sets. because mainly focused towards our resource languages, which is like English, German, um, then we have Mandarin. So those are the languages that we focused on over the last years. And now we Africans are trying to build something of our own. And one of the easiest ways to gather data here in Africa is to get speech data set, which we then evaluate towards getting the perfect version to be able to build product. So that's what our speech is. Speech to text really, and we a lot speech to text models which have been fine-tuned recently, but and what which ways are they being evaluated? Which ways are we using to test that this these data sets are authentic, these data sets are great without human evaluation or even with human evaluation. So what ASR is all about, like I said earlier, is just the data set, the speech data set that we have. And it's easier to build a product which is speech inclined, because here in Africa we have a problem of of language barrier. In Nigeria, there are several languages spoken across different community and ethnic groups. And how do we make sure that people can communicate? When you're building a product, not everyone can speak English, or not everyone that can speak English can read English. So how do you build a product that communicates to people? Or how do you do initiatives, research initiatives that actually benefit Africans? One
Hi,
of the
Hannah.
easiest ways to do.
Hello, sorry to
I
interrupt you. Your network is not coming through clearly. I thought it was just me until some people are mentioning. So if you can help optimize whatever network you're using, if not, maybe would. But then I just would like to call that to your notice.
all right, let me do that.
Say that again.
All right,
Hello?
so I'll just try to change my network. Can you hear me?
Oh. Yeah, we can hear you. It's just that it keeps breaking. Like maybe every few seconds it breaks, it cuts out. It's not just you, yeah, but sir, Honor is trying to change our network so that we can hear her clearly. So we're just giving her time to update her network so that even the recording can be clearer and everybody can enjoy the session.
Sorry, is it better now? Can you hear me more clearly?
Let's just keep going. We'll determine as we go. But yeah, it's clear at the moment.
All right, let me just share my screen.
Thank you.
Please confirm if you can see my screen.
Not yet. Okay, now yes.
All right, great. So I was saying that ASR models are the ASR models are built from ASR datasets, and ASR datasets are collected by spoken text of humans. So across groups, maybe and a couple of people, a template of what to say on diverse topics, or maybe just on basic communication, and record all of that, then define tune it and use that to build models and use that data set to solve solutions. So we have how ASR model is used to collect African data sets, and one of the approaches that is used is community-driven recordings, where people go to different communities and them a template and they're able to record their voices. And example of that, we have Mozilla Common Voice, which have a variety of data sets across different languages in the world. We also have Google Waxel, which was released in 2026. It's also a community-driven data set on voice. So another way that is data set, speech data sets are collected is the semi-supervised learning, where because pseudo labeling, where researchers use ASR models to automatically transcribe thousands of hours of unlabeled radio broadcast or podcast, or just speech data sets that are available, maybe from movies or songs. Then they use human experts in those fields to correct the errors from the machine translations, and which is a lot better and less costlier than going around communities to get data sets. The next is the image prompted speech, where you use robotic speech project, which shows user image like a scenario, yeah, bustling Lagos market, people running up and down and moving and all the whole chaos to describe a scene in modern tongue. So now it's models that have been trained, pre-trained already that would be used for this, but we're focusing on data sets, creating data sets and evaluating those data sets, because a lot of data sets are still not being created in different fields. A lot of data sets in the science space, in the education space, are not enough to train models that would that we can use to build um great solutions that can scale globally. Currently, we are all still focused on low resource. So we're using the little compute we have, the little data sets we have to fine tune models and scale them to solve solutions. So now we are how to transform data into solutions. So most of these data sets can be transformed into solutions like healthcare voice, first aid diagnostics. So we have times that people are very sick and they can't really communicate what's going on with them to their doctors, their physicians, maybe based on language barrier. And these these applications now are built for people in the rural areas to be able to communicate in their own language what they feel. And you need to understand that a lot of things, let's say for Yoruba now, a lot of sicknesses, the way they are called in Yoruba is very different from how it is in English, and the meaning, if you want to translate directly, might be very different from the English word. So we have applications like this will help um adults, people who are not multilingual or don't know how to communicate properly, to get like a first diagnosis, which then their physicians, their doctors can then go ahead with. Next, we have agricultural extensions, where um farmers, maybe big farmers or farmers in the rural areas, um used for real-time weather forecast and prediction, which directs their planting, the seasonal planting of their crops, and help monitor their crops, even help forecast or what they will be able to know based on this weather and all of that. They can prevent pests because there are a lot of climate change happening. A lot of things that most people have been used to over the years are changing. So drought and the instability in Nigeria, in the weather in Nigeria, affect farmers a lot. So applications like this, built in their own language that they can speak to and can hear them in their own language, help solve problems like this. So we also have applications for the financial space, where currently now in Nigeria there is a deadline for tax, and a whole lot of people out there do not know how to file their tax. So I'm sure there are a couple of applications that are already built in different mother tongues for locals to be able to file their tax, get them understand what to do, what not to do in their own language, in a language they can hear, not just read, because not all of them can read their language, but what they can hear, and this helps them navigate things better. So we also have a model and data set for governance and justice, which is NAFLAS, which was launched by the Nigerian government. It's an open source model for transcribing legal proceedings. Now, for this, a lot of rural people or locals in rural areas, some have a lot of court cases and all of that, and they do not understand the legal jargons that are being spoken um at the proceeding. And these applications like this, it builds into an app, helps the locals to be able to understand their proceedings. They can use that to, like, yeah, if they are allowed to record the session and be able to translate it in or transcribe it into their own language. Then this way they understand exactly what is happening. They know that their lawyers are actually defending them, and they know what more information to give to their lawyers. So the reason why African languages are challenging, first of all, is because we do not have enough funding. Then second of all is the limited data sets. We do not have a lot of data sets created. a lot of libraries. If you go to a lot of libraries, you don't find indigenous books written in our language. Neither are there a lot of data sets that have been transcribed from like movies, songs, and all of that. We do not have it as much as we have in other languages, say English, German, Mandarin. If you're listening to certain music online, let's say YouTube music, and it's in a particular Nigerian language, half the time, if it's not a like the top language like Yoruba, Igbo, or Hausa, even when it's in those languages, not all of them have the lyrics written out. And that is a struggle which you would not find for a lot of English songs, a lot of maybe Mandarin songs, because these datasets are readily available. So then the linguistic diversity. I'm using Nigeria for example. In Nigeria, Yoruba differs from place to place, from ethnic group to ethnic group. The enunciations of certain words, they differ, and that's why it's more challenging to gather this data. Now, for English, even though the enunciations are different, they are more accent based than dialect based. So it's just the tonal words, the tonal language from the different countries. Unlike here in Nigeria, where certain words are pronounced very differently, even in the same cultural group, even in the same ethnic group. Same for Hausa, same for Igbo. We have a lot of different accents and different lingua for the exact same thing, even within the same environment. From small ethnic group to small ethnic group, there are changes. And this serves as a big thing, a big hindrance and challenge to gather data sets. Then, one thing that is very particular with Africans, due to colonization, we have a whole lot of code switching. You grow up with a lot of words that are pronounced simultaneously with a Yoruba word or a Igbo word, and it's maybe when you get to find out later that you understand that these are different languages, but they are always pronounced together. And this whole code switching thing affects the data gathering, because you are supposed to gather data for Yoruba or for Hausa, and there is a lot of English nuances. If it's for Hausa, you have a lot of Arabic nuances inside the languages. Same goes for Pidgin. A lot of Pidgin has a lot of Yoruba inside, a lot of Igbo, a lot of Edo. So people constantly code switch in this part of the world. So that's why our data set is underrepresented in training. We do not have a truckload of data to train large language models. So now the need for evaluation. One of the main reasons why we need to evaluate is to ensure that these languages convey exactly what we want. They convey the right messages and they're not misinterpreted. Like I said, there are different words that sounds alike but mean different things. In Yoruba, we have Ojo, which is OJO. But according to the labeling and the tonal labeling of the words, it changes meaning. It goes from Ojo to Ojo to Ojo. And it affects a lot of data gathering, because now you're not just evaluating the text. You have to understand what it means, the semantic, and ensure that the semantic meaning of these words are not shifting. So that's why the evaluation of our languages are more critical than other high resource languages. And most of the evaluation metrics that have been built over the years are for high resource languages, and it affects tonal languages and the morphological streaming down of our own language. Now, one of the main reasons why we need rigorous evaluation is the endpoint. So for safety in like an healthcare data set, a healthcare app built on data sets, healthcare data sets with our African language, we have when the words shift and the morphological meaning also, the semantic meaning also shifts. When someone comes and say, "Oh, I'm having headache," and the app or the model misinterprets this into maybe I'm pregnant or I am having body pains, the result is going to be very different. Or if the application understands the question properly, but the answer it gives has a semantic shift based on the labeling of the text, it affects the user and misinform the user, which can cause a catastrophic um, response and by having failed diagnosis, which disrupts the whole point of this solution. Now we have resource allocation. So since African data sets are very expensive and time consuming to collect, we have the evaluation. The evaluation takes a lot of time since the data set, because you need to now label the data set accurately before you would evaluate. So if you have a language like we have enough Lagos Yoruba, but we are failing for rural dialects. Like I said, a lot of people would speak generic Yoruba. So the Yoruba in Oyo State is more popular, but that is the Oyo Yoruba. And because of the transatlantic trade, now there are Yorubas in Oyo State that are not being recognized. And if you're taking one language out of every state, you're misaligning certain people, and the solutions you're building would not reach those people. So these are one of the needs why we need to evaluate this data set critically. So it takes on every the whole variation of the languages as much as we can if we have enough funding. Then model trust. For users to adopt AI in their native tongue, the system must handle the linguistic pride of language, which is the tones. The tones and our grammar are very important because words, like I've said earlier, the words that we have sounds very alike, have different meaning. Even in pidgin, we have different expression of sounds, and could mean anything according to different way it's being pronounced. So one of the standard way of evaluating our data sets and our speech data set is word error rate. So word error rate is been is a has been we have a library trained already to evaluate this. So what he does is it's able to evaluate the errors in the word based on formulas. So it takes like it checks for substitute in the words. It checks for deletion if any word has been deleted in the text, and it checks for if any speech during the speech, if anything has been excited. Then it divides all of this. It divides all of it with the total words. So, but the problem with word error rate is it doesn't really, it's not really suited for the African language, because there are some words that even if you remove certain letters based on things that have changed over the years, how certain words are written, they still mean the same thing. So we have words like Oshogbo. Oshogbo was formerly written as Oshogbo, but now it's written as Osogbo. But with the H, if the model saw H before and during the translation H is removed, it will flag it as incorrect. but it also still means the same thing. So what error rate is not the best for evaluating our language? So we have character error rate, which provides a more granular view of the model performance in morphological rich context. So this takes more of the characters, of the context of the text, and aligns it with the semantic meaning. Then we also have phonetic density evaluation. This evaluates the meaning of the word and sees, oh, has any filler words being used or not when you're evaluating the speech. So you're able to know if a filler word has been added or not, because there are some words that actually carry filler words but can be used or can stay on their own without these filler words. So now you want to evaluate if your data set now includes filler words by what the model has produced. So now the limitation of our evaluation metrics that we own. So the current limitations we have is the English-centric bias. We have a lot of words that actually contain English-centric words. So we have, I can't find a certain word right now, but we have some words that are supposed to be Igbo or Yoruba, but they are being infiltrated with English and everybody pronounces them that way. So that would affect the the evaluation of the speech data set, because the word error rate will find English English nuances inside this text and flag it. So we also have the orthographic inconsistency. So multiple, like, language African languages have multiple ways of being written. So we have the standard way and we have the phonetic way. So there are some words that have, based on the tonal vowels and the tonal labeling, the way they are written when you're writing standardly, if you are reading like maybe African literatures written in our language, the way they are written and the way the everyday man writes are very different. And so you need to be able to put that in your evaluation when evaluating. So you check for this inconsistency while you are doing your speech to text. So we have a big lack of benchmarks. So we do not have certain benchmark that is used to evaluate speech data sets. We have a few benchmarks that are used to evaluate text data sets, but we do not have proper African benchmarks to evaluate the speech data sets. And hopefully one of us are able to actually build one of that in the next few months or years. So now we have the acoustic graph, which is the data set. So a lot of data sets are gathered in noisy environments. Some has wind, and some of those wind or background noises can actually change the way the words or the words in the data set when they are being gathered. And so when we are evaluating, we actually have to evaluate for that. So those are things that the word error rate would not take into account. So beyond word error rates, what are the ways that we use to evaluate this? So we have character error rates. So character error rate is mainly for morphological rich languages. So languages like our languages, basically a lot of languages in Africa are morphological rich and they have very different meaning, very different sounds, and the tones as well. So we also evaluate for tonal error rates. So when you change from your speech to text, you want to ensure that the tones are still consistent. The the stress on the words are consistent. So if you're going to use that, if you're going to use the data set for fine tuning, you're sure that the attention will be on the right data set. So we have linguistic sensitive gap. So where 5% word error rate in English feels different than 5% W error rate in English. So our error rate should actually be very low. But for a lot of African languages, when you have 15% error rate, that is actually like a really great error rate. But if you're dealing with languages like English, that is very, very high, because it means that a lot of things are not taken into account, a lot of deletions, a lot of insertions are up. But in our own African languages, like I said, there are some words that some letters will be removed from and will still stay the same. So this doesn't really is not interpreted as a very high error rate compared to English, German, and Mandarin. So evaluating dataset diversity and bias. So you want to evaluate the dialectal coverage. You want to, so if you're evaluating, are you evaluating for a certain dialect, or are you evaluating for the general dialect? So you want to take that into account when you're evaluating, so you can know the standardized way which your results should come out. Then the demographics of the people, the age, how do young people pronounce certain words and how do old people pronounce certain words. And this will inform the kind of data sets that you're gathering or that you're evaluating. And the way some, because of the very in some men words, some some words in the speech data set comes off different and sounds differently from how a woman is going to pronounce it. So you also want to take that into account while evaluating. And the socio-economical background. So we have, if you have seen in movies, there are certain ways that people in the higher class pronounce certain words, while people from like more rural background um pronounce the exact same words. And that's why we have people say, oh, this person is very rad, it's very local, the way he's pronouncing this word is very local. So we also need to take that into account when we are evaluating the speech data sets. Then noise profiles. When gathering the data, when we are evaluating the data set, we need to filter out the noise, and this maybe from traffic, from wind, or chatter, background chatter, to ensure that the data we are evaluating, the speech data set that we are evaluating, is clean. So now the tonal integrity, a proposed metric to isolate how often a model correctly identifies speech. So there are words that should be pronounced higher, while some are pronounced at a lower tone. So you want to evaluate this tonal error if there was a shift within your data set when you transcribe from speech to text, if the tone shifted, and this will determine the attention mechanism when you are evaluating with when you're actually training a model rather. So the semantic shift, does the meaning of the word change when you're building like an LLM to generate speech data sets? So if you're trying to evaluate a text or a speech data set generated from like LLMs or machine translation, you want to evaluate the semantic drift. You want to be sure that it still contains the same contextual meaning. So we have words like Ogun, which is pronounced as, which also means war, which also means a god in Yoruba land, and which also means medicine. So based on the labeling is how you're able to tell. But when your data set is not labeled, when your text data set is not labeled, the only way you're able to evaluate this is the semantic meaning. If the word still makes sense in the context that it is in, then the diacritic sensitivity. So this is you training your speech model to be able to predict the next word accurately using, like we said, lazy data sets. So you're ensuring that the meaning is not shifted and it's able to to predict the next word accurately. So one of the key challenges that's been solved in languages like Yoruba is one of the key challenges being solved is the tonal complexity. So we are having more and more data sets being gathered for languages like Yoruba, Hausa, Igbo, um, Ga, and Twi and across other languages, which actually understands the differences between these words through their pitch. Like I said, the way they are pronounced, some are pronounced higher, while some are pronounced lower, even though it's the same word. So this helps. So you're able to evaluate your data set if it contains, if the pitch is still right within tonal complexity. Next, we have code switching. So you're able to strip your data set or have humans change the English, French, Portuguese, or any other language that's been infused into the African language. You have human evaluators who can change it to the proper African language, or we are able to train our data set to understand that, oh, this is how it's pronounced, and this doesn't exactly mean that it's an English word. So the code switching and the hybrid evaluation. So evaluating the model switch detection, how quickly you realize a speaker has moved from Wolof to French, from Yoruba to French, from Twi to French, or to English. So that's the language identification accuracy. This is an hybrid version for evaluating code switching. While we have the code switching index, which is a metric to evaluate the difficulty of a text based on the frequency of the language translation. Then we have the vocabulary leakage, which identify words, phonemes that pollute the recognition of similar sounds. So this identify words that should actually be removed, English words that should actually be removed because they change this whole semantic meaning, the contextual meaning of the sentence of the words in general. So we have the modular evaluation pipeline. So one of the ways is of the evaluation pipeline is the normalization layer, where you standardize the text while you handle words like V versus U, because a lot of languages or a lot of our letters are not in like our keyboard, in the regular keyboard. So you want to be able to undo that, change the lettering accordingly so that it still carries the same semantic meaning. Why we have words in Hausa that we have B that has like a coil under. We have words in Yoruba that with O with a dot under. We have words in with E that has a dot under. So you want to be able to normalize this layer and fix every error or every text from your speech to text. Then we have the acoustic versus language model error. So which is decoupling whether the error came from poor audio or from lack of grammatical understanding. So we have people, I'll be using Nigeria. In Nigeria, yeah, that they mispronounce a lot of words. So you want to be sure that is it that the person who recorded that speech data set mispronounced the word, or it was just poor audio quality? So there are ways to increase the audio quality, to strip out the noise, to be able to be sure that you actually have the right speech data set. Then you check for noise. So this way we use signal to noise ratio as a metric to actually check for the noise in the background of the data set and see if that affects how the words are being pronounced, the speech accuracy, and if it reduces your word error rate and increases your or if it increases your character error rate. Now we have one of the most effective way for evaluation, which is the human in the loop evaluation, where we have a score called mean opinion score, which you have a template for your speakers, for native speakers, to grade your speech data set. So this is quite expensive because of gathering people to come and evaluate speech. But these people will be able to tell the tonal differences, if the semantic, there is a semantic drift between the speech data set, and if there's like maybe a background noise. So where these people now rate the naturalness of the model. So this mainly is they use it for data set that's been collected by speech, and it's also used for speech data sets generated by our machine models, by LLMs, by speech models. Then we have the expert correction, which maybe we have machine generated text speech data set, where we have linguists to come and identify the model error, the ones that are liable and the ones that are critical, that change the meaning of a sentence, and to remove that. Then we have intelligibility versus accuracy. So these people will evaluate that, models that have high word error rates, are they still understandable to users, or they are useless and those data sets would actually be dropped and will not be used to they will not be used for evaluation, they will not be used to build products for humans. So I'm open to question and answer.
Thank you so much. Thank you so much. Please let's give her a round of applause. I mean, well, with the sticker. Thank you. Please, if you have questions, raise up your hand. That was such an informative session. And sometimes you wonder what we're doing with the local languages in AI and machine learning. And this has answered a lot of questions for me personally. So please, if you have questions, raise up your hand to ask. I mean, before you even mention the contextual meaning of words, I was already thinking, um, how does this fit in contextually? And you'd already even answered that part of my question, and that was really very exhaustive for me. Does anybody have question in the on the call? Let's take it. If not, we'll proceed to other things. Let me check the charts. Okay. I don't think there's nothing much to really comment on the chat. Somebody had said ego in Igbo and I mean in English. I think that also speaks to contexts. Or no, would you agree about the comment of the ego in Igbo and English? I don't think there's ego. Okay, that's ego is Igbo and ego is oh yeah, I understand. Yes. So If we don't have any question, please, Honor, can you stop sharing so that we can share, we can continue. Thank you. Let me share my screen quickly. Again, just lastly, if you have any question, please either drop it in the chat um, or raise up your hand. If not, we're going to move to the next thing. Please follow us on social media. That is on X and on LinkedIn for updates, and I mean, just also to be able to boost our engagement. Believe that you should be part of the community, and if you're not, please join the community. There's a lot of conversation that goes on. There's a lot of information that's being passed in the community. I mean, we look forward to have a pre-technical session and office hours. We'd say this week has been, I mean, this month has been reached based of Saturday and today. Those has been very robust sessions that personally I have benefited from, and I believe that everybody that really leaning and listened have benefited from. So, I mean, let me just share that on the group. Would like to hear your thoughts so that we can do better. Please, the link is in the chats. Please give us feedback. We want to know what you think. I'm coming. I'll get to the chat now. Just give me a moment. Please fill in the form. Oh no. Are you still available to take a question?
Yes, yes.
Can you
Okay.
say it? Yeah.
Yeah, I can see the question. So, for the metrics, I believe that the way to actually approach choosing which metrics is by what you have. So the first thing I would say is you do the normal metrics, which is what error rate. So from what error rate, that would determine what metrics you want to try next. So if your what error rate is very high, you would try the character error rate to see or if it's a character shift or if maybe it's the toner. Then if the character shift is actually error rate is high, then you try for the toner shift. So this would help you know if it's because the words are coming off very, if the semantic shift is very high through the sound of the speech, that's why the error rate is high. Or if the tonal error rate is not high, then you can try for the phoneme error rate. So this helps you to pick which if the syllables of the data of the speech, that if there's a lot of shift in the syllables. If not, if that's not the case, then that's when you try the signal to noise ratio. So this is to evaluate if it's actually from where you got the data set, if there's a lot of background noises, and that's what is affecting your speech data set. So I think based on your first evaluation, that's what we direct if the other metrics that should be used. Does
Thank you
that
so
answer your question?
Habib, does that answer your question?
Yes, it does. Thank you.
All right, thank you. Thank you, Honor. Thank you, Habib, for the question. We're very much on time today. Thank you everyone that joined the call. Thank you especially Honor for such a session. We really appreciate. Thank you so much. And guys, till next month, we would see again or gather again for another very, impactful session. Yeah, that's it. Thank you. Thank you, everybody. Please do not forget to fill the feedback form. It would help us do better, help us know what you enjoy, and help us understand what we need to optimize to keep this going and to keep this very impactful and useful for every member of the community. Thank you, everybody, for showing up today. And thank you again, Anna. Thank you, Ifeanyi. Thank you, everybody. Bye.
Bye.